Okay.
Right. And I have shared my whiteboard. Okay, so did you manage watching the previous recordings because you were not able to attend the class?
Um, I was I was I was quite ill yesterday. I only
Mm-hmm.
woke up just now to come down so I can, but I
Yeah.
will sit down properly and go through it. Yeah.
Okay, okay. Okay, that is not an issue. That is not an issue. I'll give you a quick idea about what integration was. We started that in the last class, and then we'll talk about the concepts. Okay. Right. So integration is very important. We had some discussion in the last class about it, like when you were there in the class. Okay. So first thing is that we can only integrate something of this type. Okay. And how do we denote integration? So this is the integration sign, and we are integrating this function with respect to x. So I'll repeat. This is the function that we would be integrating, and this is how we denote it. Just like for differentiation, we use dy by dx. So for integration, we use this. This is for differentiation and this is for integration. Okay, they are just two ways of
Yeah.
representing differentiation and integration. Okay, now if the function is of this type, we integrate it this way. We write down the variable that is x as it is. We write down the old power that was n. This is the old power that is there in the function. We add 1. We divide this by the new power that is n plus 1, and we just write down a constant. Okay, this is how we integrate any function. For example, let's say the question is that you have y equals x cubed plus x under the root x. This is the function, and you have been asked to integrate it. So you will write down the integration sign. You will write down the function that is x cubed plus under the root x, and you have to integrate it with respect to this x. Okay, now how do we
Yeah.
integrate it? First we will rewrite this properly, just so we have all the powers written properly. Now instead of under root, I can write down 1 by 2 dx,
Yeah.
and now I am in the form to integrate it. Now I have something of this type, x to the power n. So I'll integrate this separately, I'll integrate this separately. X cube would become, I will write down the variable as it is, the old power. So xn plus 1, I'll add 1 divided by the new power that is n plus 1. So here it would be 4. Okay, this is how we integrate the first one. We'll write down the constant once I'm done with the integration of both. Now I'll integrate this. So this would be the variable would come as it is. Power is 1 by 2. I'll add 1. And the new power is 1 by 2 plus 1. That is 3 by 2. So it is 1.5. Okay, so I can write down 1.5, and now I'll write down the constant. So this is how we integrate. Okay, once
Yes.
you will watch the recordings, you would get a better idea, but I just wanted to give you a quick recap. So this is what integration is. Okay, and in the first class I also told you that when we are integrating something, that is giving us the area under the curve. So just know this. I'll obviously repeat this in detail once we get to that topic, but yes, this is the basic idea. Okay, now today we are going to talk about definite integral. Now, what is the difference in a simple integral and a definite integral? Any idea? Okay.
Mm,
Hmm. That's okay. Right. Now, the difference is, I'll write down the difference and then let's see if you are able to see that or not. Yes. Can you spot any differences in this one and this one?
okay. That one is, giving us the range between B and
Exactly. Very
B and
good.
A.
Excellent.
Mm.
This is the difference. Okay. So we call such type of integrals
Also, I know.
definite integrals. Okay,
Yeah.
this is what
Yes.
I know at times we don't know the terms, but we know the idea. Okay, so this is what
Yeah.
definite integral is. The integration is going to be similar, but in the last step we would be making two changes. Whenever we have definite integrals, we do not write down the constants. Always remember, In case of definite integrals, we do not have the constants, and we do another step. I'll do that and then I'll tell you. So I am going to just rub this part, and yeah. Okay, so let me write down an example. I'll explain that using the example, and then you would be comfortable with the idea. Example number 1.
Okay.
Okay. Okay. Let's talk about a simple example. Okay. So let's say you have an integral from 1 to 2, and the function is 6x to the power 4 minus 1 divided by x squared with respect to x. Now this is the question, and you need to integrate this. In order to do the integration, we are going to simplify this. How? By first simplifying the function. So I'll rewrite everything as it is. I am not going to integrate it at the first step. I'm first going to simplify this. Now x squared can be cancelled with 2, and I can write this down as 2, 1, 6 x squared minus x to the power minus 2 with respect to x. Any doubts in this? Anything that you have not understood?
No.
Okay, so I did not integrate it. I just simplified the function that I was supposed to integrate, and now I can integrate it. Okay, so this is a definite integral. Let's see how things change in case of a simple integral and in case of a definite integral. So step 1 is going to be the simple integration. 6 is going to come as it is, x to the power. The old power is 2. This time I would write down 2 plus 1. I'll divide it with the new power, plus I am going to integrate this. So sign is negative. It's negative. X to the power minus 2 plus 1. Now the new power is minus 1. So once I'll divide it by minus 1, it would become plus, right?
Yeah.
And instead of writing down the constant, I am going to make a line and write down these two limits. Now, the next step is different. I am going to plug in 2. Let's just simplify this first. This would be x 6x cubed. It's 1 time, it's 2 times. So this would be 2x cubed plus 1 over x. This is the integral, and I need to find it between these two limits. So for this, we are supposed to plug in 2 first. So I'll plug in 2 in this function. So it would be 2 cubed plus 1 by 2. Bracket closed. I'll put a minus sign, and now I am going to plug in 1. So it would be 2 plus 1. And this is going to give me what? It would give me, let's simplify this. What would be this, Munja? You can use your calculator and tell me the value. Just check, it should be 16.5 and then minus 3. So the answer would be 13.5. Just check if you're getting the same value or not.
Just 1 second, ma'am. I can check my calculator.
Sure.
Okay. I'm sorry about that.
Yeah, that's okay. That's not an issue, obviously. Just check if you're getting the same value or not. Okay. Now, Munja, I would like to repeat this example. So please just listen to this, okay? All right.
Yeah, got the same answer.
Okay, very good. Now, this is the very first example of definite integrals. Why is it a definite integral? Because it is an integral with these limits, okay? Then step one is to simplify this function just so you have every term in this type. By this type, I mean you have x in the numerator and the power is written properly, right? You do not have x in the denominator. So step one is to simplify the function. Once you are done with the simplification of the function, you need to integrate that. How do we integrate that? We integrate that using this method. So we add 1 to the old power, 2 plus 1 becomes 3, and we divide it by the new power. So this is 3, and when they are cancelled, I got 2, x cubed. And then I had x to the power minus 2. So I'll again add 1 and I'll divide it by the new power. So initially the sign was negative. Once I will divide by minus 1, it would become positive. Okay.
Positive.
So this is what we know. Once we are done with the integration, these were the two limits. How do we play with the limits? Just plug in the upper limit instead of x and write down the value in brackets. Put a minus sign. You're always going to use a negative sign. It's not for this example only. Every time, whenever you have definite integrals, after plugging in the upper limit, you will put a minus sign and then you will plug in the lower limit in the same function, and you'll simplify the answers, and this is what the answer is, right? It is 13.5, right?
Yes, ma'am.
Okay. Now this was an example. Now I need another example for this. Okay. So let's talk about example number 2. Let's say you have been asked to integrate a function from 0 to 3, and it is 5x plus 1 dx. This is the function that you need to integrate here. Okay, now this is a bit different. So you missed yesterday's class, so I'll give you an idea about it. So we had this discussion yesterday that let's say we have an integral and it is basically a factor with some power. How do we integrate it? Steps are very same. So step one would be to write this thing as it is, just like we write down the variable. Please try understanding this with the old power. Then we add 1, just like we do it in the simple cases. We divide it by the new power. And then the last step is to find the derivative of this term. The derivative of ax plus b is a, right?
Yes.
And we need to divide the derivative. This is what we discussed yesterday. Once you will watch the recordings, you would get to see multiple examples and you will understand this. Okay. So I will refer to this thing again and again, and then things would make sense. Okay. So again, this is integration. This is a definite integral. I'll write this down directly. First, I will rewrite the function just so it's written in the simple form for the proper power. Now I am going to integrate it. So first we will be integrating this. So I'll write down the factor as it is. As I told you earlier as well, 5x plus 1
Yeah.
would come as it is. Old power is 1 by 2. I am going to add 1. I will divide the new power, that would become 1.5. And I need to divide another thing, and that other thing is the derivative of 5x plus 1. Can you tell me what would be the derivative of 5x plus 1?
5.
Very well done. Very good. Excellent. Now, I am not going to write down the constant because this is a definite integral. Okay. So instead of
Yeah.
writing down the constant, I'll make a line and I will write down the upper limit and the lower limit. Let's simplify this further just so it's easier to understand. It would be 5x plus 1 whole power 1.5 or 3 by 2, whatever you're comfortable with. And then just multiply 5 with 1.5 and that would give you 7.5. So it is 7.5 and now I am in the form to just, plug in the values. Now, how do we do it? First, I'll plug in the upper limit in the function. The function is this and the upper limit is 3. So it would become 5 into 3 plus 1 to the power 3 by 2 divided by 7.5. I'll write this down in brackets. Once I'm done with the upper limit, I'll put a negative sign. And again, I am going to do the same thing with the lower limit. 5 into 0 plus 1. This thing is whole power 3 by 2 divided by 7.5. So I want you to simplify both the terms. What would be the answer for this one?
Okay.
Okay, the first term would be 128 over 15. Just check if you're getting the same one. I'm just writing down for your reference. And
Yeah.
then this would be 0. 0
Yeah.
plus 1 to the power 3 by 2. Anything power, whatever the
One.
power is, if the number is 1, it is going to stay 1. 1 divided by 7.5. And once we simplify this, we are going to get, and write down the final answer. So this is 8.4.
Yeah, that's one.
Are you getting the same value?
Yes, I did.
Okay, very good. This is 8.4. Very good. Okay. So this is how we find definite integrals. Now we are comfortable with, doing integration and calculating definite integrals. The next thing is area under a curve.
Okay.
Okay, let's start this discussion by an example. So the next topic is it is area under the
Okay.
curve. Okay. I'll write down an example and let's see. There's question number 1. Find the shaded region. I'll draw the drawing. This is the y-axis. This is the x-axis. I am going to draw the curve. Okay, this is what the curve looks like. And four, 6. This is the x-axis, this is the y-axis, this is 0, and the equation of this curve is y equals 3x squared. And now I will just write, just shade the region. So this is basically the shaded region, the yellow region, right? I'm making yellow lines like this. Okay. Now, how do we do it? Now, obviously, in order to find the shaded region, we need to find the yellow area. And it is not a proper shape. I cannot use the formula for any shape and then just, plug in the values and then find the area. Yes, I can make a straight line. I can just make a line here. And I can say that it is like a trapezium, but that is certainly not going to give me the exact area, okay? So if you are interested in finding out the exact area, for that, we need to understand the idea. If this is your curve, and if it is bounded between the line x-axis under the curve and these two lines. So at this point, it is x equals 4. At this point, it is x equals 6. I am going to integrate the curve 3x squared with respect to x, obviously, and the limits are going to be 6 and 4. This is going to give me the area under this curve above the x-axis between these limits, right?
Yes.
So this is the idea. So it's nothing new. All you need to understand is by looking at the diagram, you need to see how to make the integral. Okay, now let's integrate this. It's very, very simple. Step 1 would be integrating the function. It would become 3x cubed divided by 3. 3 and 3 would be cancelled. I'll write down 6 and 4. Now it is x cubed 6 and 4. I'll plug in 6. 6x cubed minus 4 cubed, and the answer is going to be 152 units square, because it is the area, right? Whatever the units are, you just square them, right? Any confusion in this?
No, not at all.
Okay. Now you need to understand one thing, that this time around the area was under the curve and above the x-axis, okay? Every
yes.
time the area is going to be between the curve and the x-axis. So let's talk about the other diagram and then you see. I just want you to see that the area is positive, okay? I would be referring to this thing in the next example, okay? Let's talk about another example. In that case, we'll see why I wanted you to notice this thing. Okay. Now I am going to make the curve. So it is a parabola, something of this type. This point is 0. This point is 6. The equation of the curve is y equals x squared minus 6x, and the area is this one. So you will understand a change. Okay, now again, you need to see that the area is basically between the curve and the x-axis, right? But what is the
Yes.
difference? The difference is that this time around the x-axis is above and the curve is below. Okay, so
Yeah.
everything is going to be same. We are not going to make any changes. Again, I'm going to write down the integral. The limits would be 0 and
6.
very
Oh.
6, right? 0 and 6. Okay, because this is 6, right?
Yeah.
And then the curve is going to be x squared minus 6x dx. Okay. Now, Munja, can you try calculating this and tell me the answer?
Okay.
So I'll just help you a bit in finding out the integral. That would be x cubed over 3 minus 6 x squared over 2. This would be 1. This would be 3. You need to find it for 0 and 6. It would be x cubed by 3 minus 3x squared. And yeah, now you can just find the answer and tell me. And it is okay if you're getting a weird answer, right? That won't be an issue. Just tell me whatever value you're getting once you're done.
Okay. Minus 36 units squared.
Very good. Excellent. That is correct. It would be minus 36, but not unit squared. Minus 36 is the answer of this integral. The area can never ever be negative. So you will say that the
Okay.
yes, area of the shaded region is 36 units squared. Okay, so even if you are getting a negative answer, that is completely fine. You would be getting a negative answer for such scenarios whenever y-axis is above and whenever the function has negative values, right? The function obviously has negative values on all these points because it is below the x-axis and y is negative, right? That is why you would be getting a negative area for this. So always remember the answer is going to be positive. You're not, yes, you can write down that the integral is minus 36, but the final answer, you would be writing positive 36 because otherwise you won't be getting the answer mark, right?
Yeah.
Okay, very, very good. Okay, now let's talk about another example. This time around, it would be a bit more complicated, but not that much. Uh, if you have any questions, please feel free to ask me, okay?
Okay.
Because this is important and I do understand that at times students find this difficult. So I won't lie, If you are not able to understand anything, if you have any questions, just ask me and I would just answer you directly. Okay, now I am going to make another curve and let's see how to find that shaded region. Okay, now this is the curve. I'll write down the equation and everything. So the equation of this curve is y equals x minus 2, and x minus 6. Munja, can you tell me what would be the value at this point, and this point after studying the curve? Meanwhile, I'll just write down the shaded region.
That would be 0.
Very, very good.
And 2 and 6.
Excellent. Yes, very good. Without any doubt. Excellent. It would be 0, 2, and 6. Okay, so this would be a cubic curve. The plotting is important, and that is part of our syllabus, and we have done that. So I'll obviously share the all old videos and stuff like that because you were not in those classes. So there would be some questions in which the examiner would expect you to either find the equation or just make the diagram and then integrate it. Okay, so this would be 0, this would be 2, and this would be 6. Very good. Now you are supposed to find the shaded region. So in this question, we have 2 shaded regions, right? I'll just write down A and B. This is A and this is B. Now you cannot just integrate all the function and use 0 and 6 as the limits. No. Why? Because A would be positive and B would be negative and the answer would be wrong. Like when you will do A plus B, the answer would be, this would not give you A plus B. This would not give you A plus B. Always remember, whenever you have two separate regions, you are going to write down 2 separate integrals. Okay. So for A, you are going to integrate from 0 to 2, and this is the function. So let's just simplify this. Once I simplify this, it is going to become, I'll multiply this, it would be x cubed minus 8x squared plus 12x dx, right?
Yeah.
I am going to just expand this, and this is what I would get. So you can check that later. Okay, this is A. Now let's integrate this. So it would become, just help me with writing down the integral. It would be x to the power 4, okay, 3 plus 1, divided by the new power, that is 4, minus sine 8, x to the power what, Munja? We are integrating. Old power is 2.
3.
Very good.
3.
Excellent. Plus 12 would come as this, x to the power
squared.
Very good. Divided by
2.
Very good. And then no constant because this is definite integral, 2 and 0. So let's simplify this. And now I'll plug in 2 to the power 4 by 4 minus 8 by 3 x cubed plus 6x squared. This is what I have. Can you just plug in the values and tell me the answer?
Okay.
Just check if you're getting this. Yes, Munja, are you getting 20 by 3?
My answer minus 28 over 3. I don't know how.
Okay. So did you use your calculator for this?
Yeah.
This is X. Okay. Let's see. So you can just do it with me. So it is 2 to the power 4 by 4 minus 8 by 3 into 2 cubed would be 8 plus 6 into 2 square, that would be 4. Now 2 to the power 4 is 16. 16 by 4 would be 4 minus 64 by 3 plus 24. So 4 and 24 would give you 28 minus 64 divided by 3, and the answer is 20 by 3. Okay.
Oh, yeah.
And you don't need to do minus because this is 0. Once you will plug in 0 in all these terms, you are going to get 0, right?
Yeah.
Okay. That is good. Okay. We are not done yet. This is the area for A. We need to find the area for B. So for A, we are getting 20 by 3 units. I am going to do the same steps. The only difference would be in the limits. What would be the limits this time, Munya?
2 and 6,
Very
which
good.
is 6.
2 and 6. Excellent. Okay. Now let's plug in 6. 6 to the power 4 over 4 minus 8 by 3, 6 cubed plus 6 into 6 square. So once we are done with the simplification, this would give you, sorry, this is for the first power, brackets close, minus sign, and then I'm going to plug in 2. Okay, so when I'll plug in 2, I would get the same value, 20 by 3, right? Did you understand this how? Because initially
yes.
we have done for 2. Very good. This is 20 by 3. Okay. So once we are going to simplify the first factor, first term, this would give you minus 36 minus 20 by 3. So the answer would turn out to be minus 42 to whole 3. Okay. Now the answer is negative. So what are we supposed to do? Let me write down this as an improper fraction. This is minus 128 over 3. Okay. The question was to find the shaded region. For this, you need to find the area of A and area of B. We are done with area of A. For area of B, we are getting negative answer because obviously this is the scenario for B X-axis is above, the curve is below, the answer would be negative, but we are going to write down the answer with a positive sign, that is 128 by 3. So this
Yeah.
is 128 by 3, and the area of shaded region would be A plus B. So the answer is going to be
148 by 3.
very good, 148 by 3. Excellent. This is going to be the answer. Very good. So did you understand the idea?
Yeah, I do.
Okay.
I'll do a little bit of practice, I think.
Yeah, you can just go through the recordings as well, the previous ones, and
Okay.
I can share some homework questions as well, because you would be having 3 days. So once you do that,
Okay.
you would be able to do that nicely. So I'll try my best to complete this chapter in 2 more days. Like by the end of, I would say, the last class, by the end of the next week, I would want to start statistics 1. But let's see. We don't
Okay.
need to rush. Pure maths is obviously more important. So we can start that. Okay, I'll stop sharing this. If you have any questions, you can just ask me.